Hello, it's Keith here, and this is the third of the so-called ChibiTracks programming tutorials on the 6502. We're going to be looking at my music player, ChibiTracks multi-platform music player, this time 6502, but there's a Z80 and 68000 version as well. And it works on basically all of the 6502 tutorials in all the systems in my 6502 tutorials, because I've written a multi-platform driver, a hardware abstraction layer, if you will, called Chibi Sound Pro, which handles the hardware of the system and converts the music commands to that system. So what we're going to do today is we're going to look at another chunk of the code of ChibiTracks, and we're basically this time going to look at the play routines. So let's go over to the source code. Let's take a look. Okay, so we're going to be looking at it from this point today. So this is the routine that you call during the interrupt handler, and it will update the music accordingly. So basically the way that this works is it will point IX to the start of the channel state buffer. That's a 0-page entry, and it loads in the count of the song channels, which should always be 3. That's really all that this has been tested for at this stage, and it does basically two different things for each of the channels. The first thing it does is it checks the playing pattern. The pattern is, of course, the musical sequence of various commands and notes, usually of an instrument playing events. So what we're doing here is we are loading the pattern the offset to the pattern time, and we're loading the pattern time here and decreasing 1. Now if this reaches 0, then we need to update the pattern. If it doesn't, then for this tick there's nothing to do. So if we need to update the pattern, we'll run read pattern, and that will update the pattern, loading in the next line and processing it. After that, what we're going to do is we're going to do basically the same kind of thing for the instrument. We are loading the instrument time here, and we are checking if it's 0. If it's 0, the current instrument is not, there is no instrument playing. If it's not 0, if it's 1 or greater, we're decreasing it by 1. And if it has reached 0, then we need to update the instrument. And so we're doing that with this update channel routine here. And that will process the next line of the playing instrument. Once we've done that, we use get next channel to move to the next channel, and we repeat until we've done all the channels. And once we've done that, we run the update routine, which on some systems will update the sound. A system that only has very crude beeper sound, which needs some kind of programmed event every interrupt to play the sound, needs to perform that update to make the processor do the commands. Usually it's some flipping of a bit on the sound hardware to make the sound frequencies. On some systems that's simply a return command though. Okay, so how do we actually read in the pattern? Well, basically all we're going to do is we are going to load in the address of the current line of the pattern from the offset channel pattern L and H in the channel data. We're using this routine load HL from IX, which will load the HL pair from the IX 0-page entry here. And you can see that down here. We'll have a look at that in just a moment. And so basically what that's done is it's loaded HL with the pointer to the pattern. What we're then going to do is we're going to load in the first byte of the pattern, and that will be the time until this line needs to be updated. And so that will go into the pattern T here that you saw before. Now, if applicable, we're going to multiply that up if we are allowing speed changes. And then what we're going to do is we're going to process the sound commands that this channel line contains. So that's what we're doing there. Now once we've done that, we're then going to store the updated channel position, the HL pair, and we're using store HL to IX there for this, and this just stores the L and H 0-page entries into the IX indirect offset, and IX will be pointing to one of the channel data buffers there. Load HL from IX, which we saw used there, just does the opposite, loading H and L in the 0-page from the IX entry. And you can see we're loading Y with the pointer to the first byte, the low byte, and we're inking Y here to point to the high byte for the second one. Now you will notice that we used process sound commands plus to update the pattern information. We also actually use this for the instrument update for the channel. Now that's because the scripts for the pattern and the scripts for the instrument are identical. It's the same code and the same interpreter. So how do we update the channel? Well, it's pretty similar. Basically, we're loading the channel instrument address from IX into HL. This is the pointer to the instrument script. We're then going to load in the delay until the end of this line. Now, in the case of instruments, this could be a 0, which is an end of sequence command. In that case, what we want to do is stop the instrument and silence the channel. So that's a special thing for just instruments. But otherwise, what we're going to do is we're going to multiply up the speed if required, and we are then going to basically process our sound commands with the exact same script as we did just here. So that's what we're going to do. Then once we've done that, we are going to store the instrument address back to the IX pointer, to the channel information. And then what we're going to do is we're going to update Chibi Sound Pro, which is the sound driver which updates the underlying hardware. So we pass this a set of parameters. We need to calculate a 16-bit frequency. We use a routine called the tweener, which we'll look at next time. Basically, this takes a note number, which is a number 0, 1, 2, 3, which is sort of C, C sharp, D, and so on. And we have a pitch offset, which is a shift. We can have a fractional shift between notes, and we can have a note shift. It's a single byte though, and that's what we use there. We'll see that next time. We load in the volume, and we load in the channel number, which also includes the noise bit. There's a 1-bit noise there, and we send all of that to Chibi Sound Pro set. And I've got some Chibi Sound Pro tutorials which cover the underlying hardware. So if you want to know how to make sound on a BBC, for example, then please see the Chibi Sound Pro tutorials to understand how that works. We're just looking at the multi-platform music code here. Now you'll notice here that the stop instrument routine simply loads a value of 0 and stores that as the volume here. And that was what was being executed if we found that we'd reached the end of our sequence there. So basically all of the actual jobs are done by process sound commands plus here. This is saving the new time for the current line into the channel buffer here, and then moving to the next byte of the command script, which, as I say, is the same for either instruments or patterns. And so basically what we're going to do is we're going to load in a byte from that script here. We're then going to move to the next byte in the script, and we're then going to process that byte. Now basically, depending on the byte, it will be a command. Now if it's a 0, we've actually reached the end of that line. This is what a ChibiTracks pattern sequence looks like, and also the instruments, say they are basically identical. So each line always starts with the length of time that the line is to be played for, or until the next line is processed rather. So that's that first digit there. Then we've got a sequence of commands, and they all end in a 00, or single 0 of course is the same thing. And so that's what we're checking for here. If we've got a 0, then we've reached the end of the sequence and we're returning. Otherwise, we're storing the entire byte in the B entry of the 0 page, and then we are masking out the top nibble. There's basically two kinds of commands. There's commands where the top nibble is the command and the bottom nibble is the parameter, 1-byte commands, or there's 2-byte commands where the top nibble is always 0, the bottom nibble is the number of the command, and the next byte is the parameter itself. So just depending on what kind of function we are using. So here we're checking the top nibble. If the top nibble is 0, we're jumping to the multi-byte routines. Otherwise, we are branching out to one of the commands, and that command will process the bottom nibble that we've still got backed up in B there. So for example, if the command is a noise command, then basically we are going to use the bottom bit to either enable or disable the noise. So what we're doing here is we are getting the offset to the channel number. Now the channel number also, the top bit is the noise state. So we're masking the channel number because we need to keep the channel number, but then we are masking the bottom bit, and we are then shifting that into the position for the top bit just here. So we're shifting it into that position and storing it back into the channel number. That is passed in the L register, or the L 0 page entry, sorry, on the 6502, to the Chibi Sound Pro driver, which will turn the noise on or off as required. So that's what we're doing for the noise. We've then got a variety of other commands. We've got a pattern end command, which is 10. This is only used by the patterns, not by instruments. If you put it in an instrument sequence, who knows what's going to happen. Basically what it does is it loads in the sequence to get the next pattern number, and it starts the processing of the next pattern. As I say, in theory you could put one of those in an instrument, but I really have no idea what would happen if you did. You shouldn't, but if you do something crazy, then it's on you. Now we then have a series of various commands that use single nibbles. We've got a pitch down command here. This takes the bottom nibble that was backed up in B and it converts it to a negative number, and then it stores this in the pitch setting. Pitch up takes the bottom nibble and uses this as a positive value. It stores it in the pitch setting again. We have a volume shift here. We take the bottom nibble there and we basically add it to the existing volume If we've gone over 255, we cap at 255, that's the maximum volume. If we've gone below 0, we cap at 0, that's the minimum volume. So we have a check there to make sure we don't sort of wrap our volume around. That wouldn't work very well. So those are the one nibble commands. Now there are a wide variety of unused commands that are not currently processed. And I mean, the intention of this in some ways, if you want, is that you can extend it and add your own functionality to this software. It's only very basic software. I might add my own functionality to it later, but I don't really have any need to at this stage. The tracker I wrote, ChibiTracks Pro, is a Visual Studio 2008 C# app. You can download it. The source code's included in the Z80 package on my website, and you're welcome to modify it, extend it if you can. So it's all free. If you want to make use of it, you can. So as I say, there's lots of space for extra functionality to be added if you so wish. So those are the single byte commands that use a one nibble parameter. The others are the multi-byte commands that use a full byte. So what we're going to do here is we are going to get the second parameter, and we're going to store it in X here, and then we are going to process the bottom nibble. The top nibble has to be 0 at this point for it to be considered a multi-byte command. So we're looking at the bottom nibbles here, and we're branching out to the various kinds of command that we can process. Now some of these are very straightforward. The note parameter is the byte that is stored in the current playing note, and that is handled by the tweener and ChibiSound Pro. The volume byte is the current volume. The pitch byte is the current pitch. The more interesting ones are the loop command. This is taken as a byte, and this is part of a 16-bit pair which is added to the current position within the script. Now this is a little bit tricky because you could put data in it that it becomes illogical and jumps to something that isn't script data. But what this is intended for, and this is what I use it for, of course, is you can put a loop in one of the lines of your instrument. So this byte here could be programmed to jump back to this byte here, and you can have an instrument that plays forever, and you can make wavy sounds with this. Now if you want to have a kind of key down key up effect, the ChibiSound Pro software doesn't have any kind of key up event. If you want to do something like that, you need to switch to another instrument, and so I often have a silent instrument that I can use to stop an infinitely looping instrument. ChibiTracks and ChibiTracks Pro is very simple. It's intentionally simple in some ways because I wanted something I could port viably to large numbers of systems with limited amount of time. So it's not the best software by light years. I'm not trying to claim it is. It was never intended to be. It's designed as a minimal music player to get a music file that can be played on a lot of systems without any extra work, without converting the music. That's all it was really intended for. So that's how we can use the loop. The other one we have is the play instrument command. Now what this does is it plays an instrument. Now the way we need to play an instrument is we need to actually look up the instrument within the instrument list, get the instrument address, and then load the address of the script as the playing instrument for this channel. And that's what you're going to see here. So what we're doing here is we're getting the parameter here. We are multiplying it by 2, adding it to the instrument list address. We're then loading in the address of one of the instruments. If relocation is enabled, we are adding the offset of the song. That's if the song has been loaded to a different address, to it was exported as a binary. We're setting the instrument time to 1. Now that decreases every time that the channel is updated. So if it's 1 now, the next update will turn it to a 0, which will happen immediately after this pattern was updated normally. And so that will trigger the loading of the first line of the instrument and the playing of the sound that would instigate. So by loading 1 here, we're basically forcing an update of the instrument there. So we've loaded in the address of the script, and that is all we need to do to cause the channel to play the instrument at the next opportunity. So all we're doing there is we are jumping to inst again, and in all cases that will load in the next command and process the next line of the script. And so that's how the software processes the scripts. As I say, the scripts are the same for instruments and for patterns. The only difference is the patterns end with a 1-0, which is a command to load another pattern, and the patterns are loaded in from the sequence for the channels. The IX registers I mentioned there, they point to structures. You can see the representation of them here. They contain all the bytes of data for the current in states of the channels, the current note, the current volume, the current channel and noise state, pitch shift, the pointers to the instrument and the pattern, the timeout for the instrument and the pattern, and the position in the sequence that the channel is currently processing. So that's all of the data. It's actually zeroed at the start of this. That's why this is remmed out. It's reset by the code. So that's just as there's a for reference. Anyway, as I was saying, you can go to my website and download the build scripts and everything else, including the ChibiTracks ChibiTracker Pro for Windows and also the source code for it. So there we go. If you like what you've seen, if you want to see more work done on this, please consider backing me on Patreon, because I'm kind of done on this. I don't really need this software. It really was designed for me to write games on large numbers of systems, and I don't have time to write games on large numbers of systems. So I'm only going to continue working on it if people want me to and are willing to financially back me to do so, because, as I say, I have other things I would rather do. So if you want to see work on this, please consider doing it. Otherwise, you're welcome to go to the website, download the built source code and make it better yourself and redistribute it on your own. You're welcome to do that. That's what it's there for. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.